Okay, so hello everyone. I'm so lucky to give a presentation about our new work, and my name is Zheng, and I'm from the University of Science and Technology of China. And today I will give a little discussion about the reciprocal recommendation systems in online recruitment. And here's my topic, the mirror, a multi-view reciprocal recommender system for online recruitment. And first, let me introduce the online recruitment platforms. And recently, the global online recruitment market size is growing up rapidly. And online recruitment is a convenient way for matching job seekers and recruiters. And take the Boss.jp as an example. And this is one of the largest online recruitment platform in China. And in this platform, the job seekers can browse the recommended job list and send messages to the recruiter that he or she is interested. And the recruiter can then check the information of the job seeker, and the job seeker and recruiter can talk with each other and until they finally match. And another important thing that in this platform, the recruiter can also send messages to the job seekers and he or she is interested. That means the system is symmetrical. And let me introduce the different user behaviors in the Boss.jp online platform. In this platform, and the users can have 4 types of different user behaviors. The first behavior type is search. That is, in this platform, the users can input personalized queries actively in the search box. And the platforms can then provide a list of candidates based on the query for the users to apply. And the second behavior type is actively apply. That is, the users can select suitable candidate to apply actively. For example, they can send messages. And the third behavior type is passively reply. That is, the users can reply to suitable candidates who have sent applications to him. For example, he can send the messages back. And finally, if an application is replied to, and both parties can chat with each other and decide whether to achieve a match. And therefore, in order to build a recommendation system for the online recruitment, we need to take the preference of both job seekers and recruiters into consideration. That means we need a reciprocal recommendation system. So let me introduce the reciprocal recommendation system. Different from traditional recommendation problem, which recommend the items to users. In reciprocal recommendation problem, the system recommend users to other users. Both users must be satisfied with each other. That is, both of them should be satisfied with the matching suggestion. And the left picture is the conceptual model of the general reciprocal recommendation, that is the RRS. And given a user X and a user Y, we need to calculate the preference score from user X to user Y and from user Y to user X. And we also need a preference aggregation model to get the final reciprocal preference score. And the right picture is an example of online dating recommendation, which is also a typical reciprocal recommendation problem. So to solve this reciprocal recommendation problem for online recruitment, we need to achieve the following 2 goals. And that is to get the user preference from both search and recommendation scenarios and calculate the matching probability between the job seekers and recruiters. And in order to get the user preference, we propose to model the users from 3 different views, respectively the search, active, and passive views. And in order to calculate the matching probability between job seekers and recruiters, we propose to decompose the matching probability into different parts. And we design a multi-stage output layer to get the output probabilities. And in order to train our model, we design a multitask learning loss based on the multi-stage output results. And this is the framework overview of our model mirror, a multi-view reciprocal recommendation system for online recruitment. And next, I will introduce the technical details of our method. And first, let me introduce the transformer-based sequential encoder we used in this paper. And in this paper, we can first get the interaction sequence for each user, and then we can get the embedding of each user based on his or her profile features. And in this way, the user sequence can be converted into an embedding matrix. And in order to get the embedding of the sequence, we propose the following sequence encoder. And that is, we first input the matrix into a transformer model, and then we get the embedding by a self-attention-based fusion layer. And based on the above sequence encoder, we can get the embedding of different views. And we have 3 different view encoders in our paper. That is the search view encoder, the active view encoder, and the passive view encoder. And in the search view encoder, we input the queries input by the users into the model. And we can get the embedding of different queries, and we can get the embedding matrix, and we use the sequence encoder to get the embedding of the search view. And in the active view, we input both the queries input by the users and the profile embeddings of the candidates into the model. And we use an MLP layer to fuse these embeddings, and we get the active view embedding by the sequence encoder. And in the passive view encoder, we just input the profile embeddings of the candidates that the users passively reply to, and we use the sequence encoder to get the passive view embedding. And now we need to calculate the matching probabilities of the users. And in this paper, we propose to use 3 different IPNN-based models to predict the probabilities of apply, reply, and match. And we further get the match probability of the product of the 3 different probabilities. That is, let me take this as an example. If we show the recruiter R to job seeker S, the probability of job seeker S can match with the recruiter R. It's the probability of job seeker S send application to R, and multiply the probability that the recruiter R reply to the job seeker S. And then we also need to multiply the probability that they have a chat and finally get matched with each other. And so the final match probability is the can be calculated from the 3 different probabilities. And after getting the probabilities, we can now get the mid-stage loss function. And we use the cross-entropy loss as the loss function for each stage probability. And we can get 6 different loss functions. And the loss function L1, L2, and 3 is designed for the job seekers as the active party. That is, the recruiters are shown to job seekers, and they can select the job seeker they prefer. And symmetrically, when the recruiters are the active party, we can get the L4, L5, and L6 corresponding to the 3 stages. And we add these 6 loss functions as the final multi-stage loss function. And now let me introduce our experiment results. Our data sets come from a real-world online recruit platform that is Recruitment. We collected 5 different data sets from 5 different domains, respectively arts, manufacturing, marketing, service, and technology. And this table contains some statistic information of our data sets. And to demonstrate the effectiveness of our model, we compare our mirror model with all the baseline methods, and the results are shown in the table. And we can find that our mirror model significantly outperforms all the baseline methods across various evaluation metrics on different data sets. And this is the ablation study results of our model. We did ablation study to test the effectiveness of each component. And we can find that all the 3 user views contain essential information for user modeling. And moreover, the multitask modeling method is also effective. And to further evaluate the effectiveness of our proposed mirror model, we conducted a series of online A/B tests in our online recruitment platform for both the job seekers and the recruiters. And the job seekers and recruiters for all the models were randomly selected, and the models were deployed online simultaneously for 6 days. And from the results, we can find that our mirror model performs significantly better than other models, which clearly demonstrate the effectiveness of our multi-view user modeling method. And finally, let me make a summary. And in this paper, we studied a novel problem, that is reciprocal recommendation for online recruitment. We propose a novel model, which is a multi-view reciprocal recommendation method with a multi-stage output layer. And our method achieved a good result on both offline and online experiments. Okay, and this is the end of our presentation. Thank you.